Today we show the initial load and bidirectional synchronization between a Datacom and a Postgres. We have a Datacom example database, and the goal is to load this database into a Postgres and to establish bidirectional real-time synchronization. The demo environment consists of a ZOS 2.1 with Datacom, and Ubuntu with Postgres 9.6, or Windows 10 with the control board, and of course tcVISION. These are our two components, mainframe on the left and the server on the right. We start with creating the metadata. For this we use the Datacom catalog tables. We need an input, an output, and a replication. We import from Datacom to the mainframe. We enter the URT and select the table. The schema has to be changed. Our target schema is called demo. Now we can see the tables, input side, output side, and the replication as links in between. The structures on the Postgres side can be created automatically using the recommendation of tcVISION. Now for the initial load. We already prepared two Datacom backups. We use one of them now. The processing is done in processing tasks that are generated in a script language with the help of a comfortable wizard. We want to set up a bulk transfer. This bulk transfer is based on a Datacom unload. It's not important whether physical or native backups are used. We specify the file. The highly performant Postgres direct loader should be used as target. Of course we have to define it here. There are comfortable wizards for this as well. Now we have the processing task. It starts and is done immediately. 200 records were transferred. Then we check the Postgres for the data. The data is available, so now we can start a real-time replication. The starting point for the real-time replication is a log reader that reads the data via the RxX interface of Datacom. We just have to select a few definitions. We'd like to use the RxX interface. Then we have to select the file. The changes should be sent without processing in order to reduce CPU cycles on the mainframe, so we select stage 0. The output is remote, our Ubuntu Linux. On the other side, we have already prepared a script that receives the data, prepares it, and integrates it into the target database. When starting the sender, the receiver is automatically started as well. and a link is established between them. With a batch run, we create 2 updates and 1 insert. They can be seen in the statistic of the integration script. The changes arrived here. Now for the reverse replication, from Postgres to Datacom. We start with creating the output target. Then we name the output target, Datacom ZOS. Of course the type is Datacom. The connection string conforms to that. We have to select a URT that is later used for the access. Again, comfortable wizards help with the selection. A green tick indicates that it is a URT. Now we have 2 output targets for both directions. The next step is another import of the metadata. We only need an input. Our Postgres on the Ubuntu Linux. We enter the access data and select the table. This time an output. For the output in Datacom, we import again via the Datacom catalog tables. Both tables were created according to the already existing definition, input and output. Those 2 just have to be linked. And because they have the same type, they can be linked automatically with the button in the middle. We can start with defining our tasks. Let's start with the Postgres reader that reads out the log files in Postgres and saves them in the staging area. Here we enter the link to the Postgres. This time we want to write in stage 1. This means that the records are analyzed and written into files by transactions. For that a local directory was created, which can also be network attached, storage or something similar. The name with the timestamp in UTC gives us the sortability. We tell the transaction manager to analyze the transactions and to sort the output data by transactions. Restart information ensures that we can continue right here when the script was closed. The subsequent task sends the data to Datacom. For that the data is processed. Again, our source is the staging area. We can see the same directory in here that exists in the data folders. This time we choose stage 3. All processing is done on the server in order to reduce CPU cycles on the mainframe. The output is our ZOS, where there's a receiver that only executes the Datacom commands. We set up the constellation, first our reader and then our sender. The sender starts the receiver that integrates the data into the Datacom. To generate updates, we go to the Linux surface and use the Postgres command line tool. We change the database to database Datacom and have it give us 4 data records. Here we have the current rate. The update is done and we can check whether the changes were applied. We now have half the current rate. We can check in the Datacom with a report whether the values arrived. Here we also have the half values. What did we see today? We saw that tcVISION can capture change data effectively from data sources on the mainframe, transport it to the server to be processed, and then integrate it into the target database. On the other side, we saw that tcVISION can also capture the change data from PC sources, process them on the server, and send the processed data to the mainframe to be integrated into respective target database. Changes applied by tcVISION are prevented from being replicated during a bidirectional replication. Thank you for your attention.